Hello everyone. Question is a company has an application that uses an Amazon RDS PostgreSQL database. The company is developing an application feature that will store sensitive information for an individual in the database. During a security review of the environment, the company discovers that the RDS DB instance is not encrypting data at rest. The company needs a solution that will provide encryption at rest for all the existing data and for any new data that is entered for an individual. Which combination of options that the company used to meet these requirements? Choose two options. Option A, create a snapshot of the DB instance. Copy the snapshot to a new snapshot and enable encryption for the copy process. Use the new snapshot to restore the DB instance. Option B, modify the configuration of the DB instance by enabling encryption. Create a snapshot of the DB instance. Use the snapshot to restore the DB instance. Option C, use AWS Key Management Service AWS KMS to create a new default AWS managed AWS or RDS key. Select this key as the encryption key for operations with Amazon RDS. Option D, use AWS Key Management Service AWS KMS to create a new CMK. Select this key as an encryption key for operations with Amazon RDS. Option E, create a snapshot of the DB instance. Enable encryption on the snapshot. Use the snapshot to restore the DB instance. Correct answer is option A and option D. You can download the complete list of recently updated contents from the link provided in the description. If you like this content, please like and subscribe. Question is, a company is hosting a web application on Amazon EC2 instances behind an application load balancer ALB. The application has become the target of a DOS attack. Application logging shows that requests are coming from small number of client IP addresses, but the addresses change regularly. The company needs to block the malicious traffic with a solution that requires the least amount of ongoing effort. Which solution meets these requirements? Option A, create an AWS WAF rate-based rule and attach it to the ALB. Option B, update the security group that is attached to the ALB to block the attacking IP addresses. Option C, update the ALB subnet's network ACL to block the attacking client IP addresses. Option D, create a AWS WAF rate-based rule and attach it to the security group of the EC2 instances. Correct answer is option A. Question is, a public subnet contains two Amazon EC2 instances. The subnet has a custom network ACL. A security engineer is designing a solution to improve the subnet security. The solution must allow outbound traffic to an internet service that uses TLS through port 443. The solution also must deny inbound traffic that is destined for MySQL port 3306. Which network ACL rule set meets these requirements? Option A, use inbound rule 100 to allow traffic on TCP port 443. Use inbound rule 200 to deny traffic on TCP port 3306. Use outbound rule 100 to allow traffic on TCP port 443. Option B. Use inbound rule 100 to deny traffic on TCP port 3306. Use inbound rule 200 to allow traffic on TCP port range 10242 to 65535. Use outbound rule 100 to allow traffic on TCP port 443. Option C. Use inbound rule 100 to allow traffic on TCP port range 10242 to 65535. Use inbound rule 200 to deny traffic on TCP port 3306. Use outbound rule 100 to allow traffic on TCP port 443. Option D. Use inbound rule 100 to deny traffic on TCP port 3306. Use inbound rule 200 to allow traffic on TCP port 443. Use outbound rule 100 to allow traffic on TCP port 443. Correct answer is option A. You can download the complete list of recently updated contents from the link provided in the description. If you like this content, please like and subscribe.